Another very big advantage of using a random forest model is that it helps us calculate the relative importance of variables used. So if you have 10 different variables and you're not sure which of the variables is important to your model, random forest helps you decide the relative importance of variables by a plot called the variable importance plot. So let's say you have 10 different variables, IV1, IV2 and IV10. So you have 10 independent variables and you want to find out which of these variables are important. So this process is also known as feature selection. So features is used to refer to the independent variables. So the process of selecting the important features is known as feature selection. Why do we want to select important features? Because if you include unimportant features into your model, it usually leads to overfitting. So we have traditionally seen in linear and logistic regression. In linear and logistic, if you include too many independent variables, it might lead to overfitting. Now, how do we do feature selection in these models? In these models, we get the p-values. So using the p-values, we try to omit the variables which has greater than 5% p-value, and iteratively we recreate models and then we figure out which variables are important and which variables are not. Now that is a very tedious process in linear and logistic. In decision trees and in case of random forest especially, it provides us a function which helps us directly calculate the relative importance of the features that are used. So once you do feature selection, you may get a plot like this. So this is on the census data set which you have seen. So this is the relative importance of variable. We get two plots. Both of them, they measure the similar concept, which is how important a variable is to the model. So for example, in this plot, you can see capital gain is the most important variable. It has the most relative importance. Next is capital loss and so on. So these few variables you can say are not important to your model. And the top few variables are very important. Now, a lot of people also find out the relative importance of variables using a random forest model and then take this information back to a linear or logistic regression model and only use the variables which they find important through random forest into a linear or logistic model. Now that is also done very commonly. Why is that done? Because the process of selecting feature importance in linear and logistic is a little tedious. So we try to borrow the idea from random forest and then take only the important variables to linear and logistic. But let us see how are these two charts formed. So what is the process of forming the variable importance plot in random forest? So we will first talk about the first chart, which measures the decrease in accuracy as is shown here. So this measures the decrease in accuracy. So how is this chart calculated? So what is done is each variable is picked one. So let's say we pick this variable, and instead of the actual values of the variable, we just permute some random numbers for this variable. So we will permute some random numbers for this variable instead of the actual values, and then we try to rerun the model. So obviously the model will lose its accuracy because one of the variables has been permuted with random values or permuted with junk values. So the accuracy of the model will fall. Now we measure how much has the accuracy fallen. Now if the variable is very important to the model, the accuracy will fall a lot, because obviously if you take a very important variable and replace its values with junk values, it would lead to a large fall in accuracy of the overall model. So this concept is used as to find out the relative importance of variables. The variable which results in the largest loss in accuracy is the most important variable, and this accuracy measurement is done on out of bag sample of data. So this is not done on the training data, this is done on out of bag sample data, and hence it is a very good parameter to estimate the relative accuracy of a variable. Now let's see the other variable, the other drawing that we have. So this also measures the relative importance of variables, but using a slightly different concept. So what do we measure here? We try to measure the relative decrease in Gini index. In this chart, we take each independent variable. So let's say we take capital gain and we measure the decrease in Gini index or the decrease in impurity as a result of this single particular variable. So we measure how much is the Gini index decreasing as a result of capital gain. Of course, if the decrease is a lot, this means that this variable is important to the model. Similarly, we will check how much is the Gini index decreasing for the variable age, or what is the result in purity, or how much is the purity increasing or the impurity decreasing as a result of the variable age. So using this approach, we measure the variable importance in the second diagram. Now this is done on the training data. This is not done on the out of sample data. This is done on the training data, and hence this is not a very accurate measurement of the relative importance of variables. The first plot is what gives you a more accurate picture. So using these two concepts, we measure the variable importance of all the independent variables used in the random forest model. Let us see how do we compute the variable importance plot in R. So we will try to run the variable importance plot on the census dataset, which we have seen in the previous video. So these few lines we have already discussed. These few lines. The additional change when you want to draw a variable importance plot is you need to write importance is equal to true in the model. While you create the random forest model, we have to write importance is equal to true. So this allows the algorithm to store additional information, which is then used to compute the variable importance plot. Now after this, the process is very simple. You use the variable importance plot function and the name of the model. So once you run this, you get the variable importance plot, which we have already discussed. So it's pretty simple to get the variable importance plot in R. In the next section, we will do a case study where we will apply everything that we have learned about random forest and decision tree.